So welcome to all of you. So we go to the next chapter, that is chapter 3rd, numerical differentiation and integration. Okay. So here how to find the derivative, first derivative and second derivative at a particular point, that we will see. So we have given the some data. Okay. So with the help of data you have to find the derivative dy by dx at some point, d2y by dx square at some point. That we will do. Okay. So now we'll first see the numerical differentiation. In the second part, we'll see the numerical integration. Okay. So how to integrate? That means what for integration. So suppose a is to b e raised to x square dx. Suppose this is 3 to 4. Suppose. So now we know that e raised to x square is not integrable. E raised to x square is not integrable. So that means you cannot evaluate by our usual method. So integration from 3 to 4 e raised to x square. But with the help of the numerical methods, we can find the approximate value of the integration from 3 to 4 e raised to x square dx. So that will be the numerical integration. That is the second part. We will see how to integrate e raised to x square from 3 to 4 with the help of the numerical analysis. That is numerical method. Okay. So that is the next part. But before that, we will see how to differentiate, how to find the derivative at a particular point with the help of the numerical analysis. Okay. So suppose we have given a set of the values x0, y0, x1, y1, dot x and yn for x and y. So these values are provided to you, and we have to find a derivative. We have to form. That means you have to derive the formula to compute the numerical differentiation. So for that, so we have already seen the Newton's forward difference interpolation formula, forward difference interpolation formula, interpolation formula. Okay. So instead of p, I will substitute here u now. Okay. Instead of p, I will put u now here. What is that? Y naught. This is your p actually. So p, that is u, delta y naught, and so on. Okay. So this is the Newton's forward difference interpolation formula. Okay. So now here what you know, that your x is equal to what? Your y is equal to y of x. This is what? Y of x, and x is equal to x naught plus uh. X naught plus ph. Actually the x naught plus now. So we have to differentiate this. We have to y the function of x now. You have to differentiate y. But now here the y is the function of u now. So we'll apply the chain rule. Dy by dx is dy by du into du by dx plus 1 upon h. So this is what 1 upon h. Why? Because if you differentiate dy by, so du by dx, so du by, oh, this is the wrong, du by dx. Okay, so du by dx is what? Here u is equal to, so u is equal to, this implies that u is equal to x minus x naught upon h. That is what? 1 upon h, x minus x naught, right? So du by dx, and du by dx is what? 1 upon h is constant, derivative of x is 1, so this is 1 by h then. Okay, so this is 1 by h. Now we have to differentiate this. So derivative of y naught is constant, so this is 0. So derivative of this is what? Del y naught only, plus this is 1 upon 2 factorial, so I write this is 1 upon 2. Okay, and what is the derivative of this one? This is twice u minus u, twice u, this is u square minus u, this is what? U square, so this is what? Twice u minus 1, del square y naught, del square y naught, plus 1 upon 6 I write here. Now what is this? This is nothing but, if you multiply this, what is this? This is u minus 3u plus twice u square minus 3u plus twice this product. Okay, and if you multiply by u, then this is what? U cube minus 3u square plus twice u. Okay, so before that, what we will do? Before that, okay, so we write here what? X is equal to x naught plus uh. Before that, we will expand this so that easily you can find a derivative now. Plus 1 upon 2 factorial, that is 1 upon 2 u square minus u. Okay, so that you will find easily the derivative. So before that, we will expand like this. This is what? This is u cube minus 3u square plus twice u del square del cube y naught del cube y naught plus dot dot plus 1 upon n factorial. So how to expand this? So it will be okay. So we are ignoring this. Okay, we are ignoring this. Plus just we write this 1 upon n u minus 1 u minus 2 u minus 3 dot 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 u minus n minus 1 10 raised to n y naught. We are ignoring this. Okay. So before that, we'll find one more term. We will find one more term. Okay. So that is what just we write here. So what is that then? See, this is what? This is u minus 1, u minus 2. Okay. So now, then I multiply this is what? U minus 3 then. U minus 3 then. What we get then? Just we will simplify this. Just we will simplify. First we will multiply this one. U raised to 4 minus 3u cube plus twice u square minus 3u cube minus 3u cube plus 9u square minus 6. Okay. So simplify this. So this will be what then? So I will write here plus dot dot dot. Okay. I will write the one more term. 1 upon 4 factorial. That is 24 plus 1 upon 24. So this is what? U raised to 4. How many cubes? Minus 6u cube. How many square? Plus 11 u square minus 6 minus 6u minus 6u. Okay, minus 6u. Okay, so del raised to 4 y naught. Okay, now we'll differentiate this now. Dy by dx. Now easily we can differentiate this. So dy by dx is nothing but dy by du into du by dx. Okay, now this implies that u is equal to 1 upon h x minus x dot. So du by dx is 1 upon h. Du by dx is 1 upon h. Okay, now we are differentiating this with respect to u. Derivative of y naught is 0. So this is del y naught plus 1 half twice u minus 1 del square y naught plus 1 upon 6 3u square minus 6u plus 2 del cube y naught plus 1 upon 24 u 4. You have to differentiate this with respect to u now. This is what? 4u cube minus 18u square minus plus 22u minus 6 then raised to 4 y naught, and just I will write here plus dot dot dot. Okay, I am not taking the derivative of this one. I will write this plus dot 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 and it is complete. Okay. Okay. So I want to find dy by dx at x naught. Okay. So put x is equal to x naught. We get, if you put x is equal to x naught, so x naught, we get u is equal to 0. We get u is equal to 0. I will call this as 2. I will call this as 2. Then 2 implies dy by dx at x is equal to x naught is equal to at x is equal to 1 by h delta y naught plus, oh, we don't write the sign. So this is what? U is equal to 0. Then this is minus half del square y naught. Okay, don't write the sign. Then this is u is equal to 0. 2 upon 6 is 1 upon 3 plus 1 upon 3 del cube y naught. Then this is minus now. All are 0 now. minus 6 upon 24, so minus 1 by 4, minus 1 by 4, 10 raised to 4, 10 raised to 4, y naught, 10 raised to 4, y naught, plus dot dot dot, plus dot dot. So this solution of the problem is depending on this one what, so depending on the difference table, so easily you can write this is plus 1 by 5 and so on. Okay, now we have to find the second derivative then. We have to find the second derivative now. So we differentiate this once again. d2y by dx square should be 1 upon x square. So d2y by dx square is again d by dx of dy dx is dy by dx. Okay, so this is nothing but d by du of dy by dx into du by dx. Okay, so that is 1 upon h, so this will be 1 upon h square, 1 upon h. Now this is 1 upon h and that 1 upon h square. Now we differentiate this. So this is what then? So derivative will be what then? So this is what 1. So minus. So this is what del square y naught. Del square y naught plus 1 upon 6. Plus 1 upon 6. 6 u minus 6 del cube y naught plus 1 upon 24, 12y square, or 12 not, this is what, this is u. Okay, take care of this is not y. So 12u square, 12u square minus 36u plus 22 10 raised to 4 y naught plus dot dot dot. So this is equal to 1 upon h square. This is 1 upon h square. Del square y naught. Del square y naught minus. You have to put x is equal to x naught. X is equal to x naught. Then d2y by dx square. X is equal to x naught. It's 1 upon h square. 1 upon h square. Del square y naught minus del cube y naught, because what, u is 0, put it then u is equal to 0. So I'll call this as a 3 now, then u is equal to 0. So 3 implies, okay, del cube y naught. So now u is equal to 0. 22 upon 24, so that is what, 11 upon 12. So this is what, 11 upon 12 plus 11 upon minus, so this is plus now, 10 raised to 4 y naught. I will write the further terms for our convenience. Minus 5 by 6 10 raised to 5 y naught plus 137 upon 180 10 to the power 6 y naught plus dot dot dot. Okay, so for solving the problem we don't need anything now, just we want only this. Okay, so now this is the formula to find the first derivative and the second derivative. Okay, now remember this formula, 1 upon h this, and this is 1 upon h square this. Okay, so for the second derivative and for the first derivative, only remember this formula. Okay, now we solve the problem so that you will understand how to apply this formula to find derivative of y at a particular point. Find dy dx of dy by dx at x is equal to 0.1 from the following data: your x, your y, 0, 0.1, 0.2, 0.3, 0.4. The values of x should be the equally spaced here. Okay, so the values of x should be equally spaced in the numerical differentiation as well as numerical integration. Okay, so this is 1, 0.9975, 0.99, 0.9776 and 0.9604. Okay, so we prepare a difference table. So this is x. Prepare a difference table. So this is x and this is y. Okay, so 0, 0.1, 0.2, 0.3, 0.4. Your y is 1, 0.9975, 0.99, 0.9776, 0.9604. Okay, so now your del y. Okay, so this minus this is minus point 0.0025. This minus this is minus 0.0075. Okay, minus 0.0075. Then this minus this is minus 0.0124 minus 0.0172. This minus this. Okay, so what you have to do? This minus this value you have to write here. This minus this, you have to write the value of this. This minus this, this minus this, you have to write the value. Okay, now del square y. Del square y. What you have to do? You have to do this one. This minus this, this minus this, this minus this. Okay, so I write that value is minus. You have to use the scientific calculator and you have to write the value of this one. 5. Okay, so minus 0.0049. Okay, you check whether the values are correct or not. Whatever the answers given in the book, so I write just as it is now. Okay, so this may be wrong now. These values may be wrong now. So you have to write the correct value. You have to check whether these values are correct or not. Del cube y. This minus this. So this is what this minus this. This is 0.001. This minus this also 0.001. And del to the power 4y is 0. Okay, so this is very nice. Okay, so we don't want this. Okay. Okay, so we write the formula for dy by dx now. Dy by dx is 1 upon h. So what? Del y naught. We write the formula for del y naught minus 1 half del square y naught plus 1 by 3 del cube y naught. Okay, because del to the power 4 y naught is 0, so we close this bracket here. Now you have to write the value of dy by dx at x is equal to 0.1, not x is equal to 0. This formula for what? If you want to put the upper value, so upper values are only for the y naught. Okay, but your y naught is here what? 0.1. So that means what? From the table you have to put the second value, because what? This is the second one. So you have to put the values in the second values. Okay, from the column of that one, you have to put the second value of the column. Okay, so 1 upon h what? Interval difference is 0.1. So 1 upon 0.1. Okay, now del y naught. So your y naught is what? This value you have to put what? Minus 0.0075. This is the what? This is their y naught actually. If your x naught is 0, now your x naught is 0.1. So this is the second value. So therefore you have to write. So if you want to find the value at 0.2, derivative at 0.2, then you have to take the third value of the each column. Third value of the each column. Then your formula will be only up to del square only. Okay? Because the third value is not there. So that means what your formula is closed here now. Del square. Because del cube y naught will be the 0 if your x is 0.3. Okay? So now the second value you have to put here, minus half. Second value of this minus 0.0049 plus 1 by 3. The second value is 0.001, and you have to write this value. Okay, so according to me, just calculated value will be minus, all terms are negative, 0.0502. Okay, so note this how to put the values of del y naught. This is depend on the x naught. So x naught, this is not here, you don't want to take the upper value only here. So depending on the your x naught is 0.1. Okay, so take the care of this one. How to apply this formula? Just remember this formula, write this formula as it is. But your y naught is here what? This is your y naught, 0.9975 is y naught here. This is not your y naught. Okay, so for this problem, okay, actually the y naught is 1. But what you want, you have written here 0.1, therefore your y naught is this. This is your x naught, this is y naught, this is y1, y2, y3. Then this will what? This is now, this start from here. Now this is your del y naught, del y naught, this is del y, this is del y naught, del y1, del y2, del y3. This is del square y naught, del square y1, del square y2. This is del cube y naught, this is del cube y1, there is no del cube y2. Okay, so now this is del raised to 4 y naught. Now here del raised to 4 y1 is 0 and so on. Okay, now we'll solve one more problem. So here what, the difference table is very important. Now here you have to do these calculations very carefully. Okay, so we write one more thing. So we have given, okay, given that next example, t and theta in terms of radian. Now this is 0.52. What value is given, no problem for this one. Okay, so 0.105, 0.044, this should be the 4, because that directly jumps to the 0.02. That means this is 0.04, 0.06, 0.08, 0.1, that is 0.10, and 0.12 now. Okay, so the values are given 0.168, 0.242, 0.327, 0.408, and 0.489. Okay, calculate the angular velocity at t is equal to 0.06. You have to find the angular velocity at that, right? That is what. So you have to find dt by d theta. You have to find. So that means what here? You have to find dt by d theta at theta is equal to 0.6. Next, this is, you have to find this value. Okay. So solution. We'll write here t and we'll write here theta. Okay. So 0.02, 0.04, 0.06, 0.08, 0.10, 0.12. Okay. So value is what? 0.052, 0.105, 0.168, 0.242, 0.327, 0.408, 0.489, 489. Okay, this is theta. Okay, now del theta. Okay, so del square theta, del cube theta. So angular velocity is what we have to find, d theta by dt, d theta by dt at t is equal to, this you want to find at t is equal to 0.6. Okay, okay, so just we'll make a difference table. So I will directly write this what 0.053, 0.063, 0.074, 0.085, 0.085, then 0.081, 0.081. Okay, now next is what 0.01, 0.011, 0.011, minus 0.0040. Okay, now del cube, so 0.001, 0 minus 0.015, 004, then raised to 4 theta, then raised to 4 theta, minus 0.001, minus 0.15, minus 0.019, then raised to 5 theta, minus 0.014, 0.034, then raised to 6 theta is 0.48, 0.048. Okay, so we'll write first value, okay, dy by, okay, instead of d theta by dt, we'll write in terms of d theta by dt. We'll write a formula. This is what 1 upon h, 1 upon h is what del theta naught. Okay, del theta naught plus, see this is instead of y there is theta now, del theta y, or minus, so formula is what minus 1/2, alternate plus minus. Okay, so minus 1/2 del square theta naught plus 1/3 del cube theta naught plus 1 by minus 1/4, minus 1/4 del raised to 4, del raised to 4 theta naught plus, this is minus, okay, plus 1/5 del raised to 5 theta naught. Okay, okay, so we'll write formula. This is what plus del raised to 6 theta naught. Okay, this will be a formula. So here h is equal to what 0.02, 0.02, t is equal to what 0.06. Okay, we'll write this is what d theta by dt at 0.06. This is equal to 1 upon 0.02. We have to put the proper values of this one. Where is 0.06? Where is 0.06? Is here. Okay, so this is 1, 2, 3, 4, fourth value. So from the table you have to take the fourth value. So your fourth value is what? So this is your fourth value, right? So this is what 0.085. This is your del naught minus 1/2. What is your fourth value? So 1, 2, 3, 4. This is what minus 0.004. Okay, now then this is what, this is your fourth value. Plus 1/3, plus 1/3, 0.004. Okay, so close. It is closed now. Because what? So 10 to the power 4 will be 0 because there is no fourth value. So we get the value here. So we get the value is here 4.5983. So therefore the angular velocity is 4.93 radian per second. Okay, so this is what, so therefore velocity is equal to 4.5983 radian per second, radian per second. Okay, so the units are given here. T seconds unit is given, and theta in radians is given. So radian per second is the unit of the velocity. Okay. So now here what if you want to point to suppose that point. Okay. So then this is what the second value. Then you have to put the second value here. This is second value. This is second value. Second value. Second value. Second value. And your delta to the power 6 will be 0. That means you have to write the value up to this one. Okay. So what in this way you can solve the problems at any point. You can find a derivative if you have given the data. So to find the derivative, so values of the whatever the x should be the equally spaced. Okay. So if the values of x are not equally spaced, then you cannot find the derivative with the help of this numerical method. Okay. So I hope that you understand this one. If you want to find the second derivative, then apply that the second derivative formula. What? So second derivative formula. Okay. I hope that you can solve all the problems of the first derivative and the second derivative also. Okay. So I hope that you understand this one. How to differentiate, how to find a derivative at a particular point, at any point from this one. Okay. So what at any point from this one we have to find. So this is the exercise. What find the angular velocity at t is equal to 0.2, at t is equal to 0.2, or at t is equal to 0.04 now. Okay. So from this you can make a two problems for find. So instead of this what 0.6, so 0.06, just find the angular velocity at t is equal to 0.02 and 0.04. Okay. So that is the exercise to you. I hope that you can solve this one. Okay. So now we'll stop here. Thank you.